Hi MOS 4472 team. In this video, I'm going to take you through chapter 8, which discusses documenting systems and processes. We are going to be discussing processes for the next 3 weeks. So this is just kind of an introductory chapter that explains why process documentation is important and how it can be done. So in terms of what we are going to discuss, we're going to discuss why businesses document processes and systems, the different types of documentation techniques that organizations may utilize, how to document business processes and information that flow throughout an organization, and how to document data movement in a company system. So we're not only looking at processes, but also how data and information moves in the system. Your key learning objectives, or what you might be tested on, is explaining the goals of documenting systems and processes, differentiating among the various documentation techniques, showing how a flowchart illustrates a system or business process. And on the final exam, I always have some kind of flow chart. So I either give students a process description and ask you to draw it in a flow chart, or I'll provide you with a business flow chart and ask you to provide a description. So please pay close attention there. And then show how a flowchart illustrates a system or business process. Let's learn how to explain the goals of documenting systems and processes. Documentation is a formal record that describes a system or process. Companies use documentation for several reasons. They may need to comply with laws and regulations. We've learned about Sarbanes-Oxley or SOX in previous chapters, and SOX requires US traded companies to have their process documented. So one of the first jobs I had when I was at Vale was documenting all the processes, so the documentation was available for our auditors to review and sign off on the fact that we were in compliance with SOX. They're also good for troubleshooting and maintenance. If you understand the process, you're able to figure out what to do if there is a problem, or alternatively, you might find more efficiencies by seeing the process and the flow of information and how things get done in the organization. Documentation also ensures consistency across employees' work and how employees are trained, especially in large organizations. For example, let's think of a grocery store with a cashier. If they have a manual on how to do various transactions, you're ensuring that everyone accounts for everything according to the rules of the organization. It just ensures that there is consistency and it avoids errors. It captures usable information for process improvements, as I mentioned in the other point above. Once you can see how a process is done, you might be able to streamline it and figure out what the inefficiencies are. And then documenting and evaluating internal controls activities. By documenting a process, you can see how safe and secure it is and the potential for fraud or misstatements that would occur within that process. There is a hierarchy to documentation. So on the high level, we have systems documentation, and this is an overview of the computer system with details of the system design and architecture. Below it, we have program documentation, and this provides us with a detailed description of the system's programming, logic, and source code. So here you can see how the system's actually built, what it consists of. Then we move on to kind of less technical documentation. We have operator documentation, which is information necessary for technical operators to execute and support the system. And then we have user documentation, which is instructions for system users on how to interact with the system. For the most part, we are going to look at user documentation because we are not IT specialists and we can't really understand binary code, etc. So system documentation is the overview of the computer system, and this is the most granular view. Here's a great chart that kind of explains what is incorporated in system documentation. So we see who the primary users of this documentation are, and this is usually the developers of the system. And sometimes auditors will look at this documentation just to understand the architecture and design of the system they're auditing. The elements that are captured in this documentation include the system architecture, the technical design, the user interface design, so how the user interacts with the system, the various inputs and outputs to the system, the high-level processing logic, and how the system interacts with other systems in the business. And the forms of documentation that are incorporated in system documentation include narrative descriptions explaining what is occurring, various flowcharts showing how things move through the process, data flow diagrams that show how data moves through the information system, and enterprise relationship diagrams, or ERDs, that we're going to talk about a little later. Then we have program documentation, and program documentation is also referred to as software or technical documentation, and this describes a detailed analysis of the program and its logic. So it explains how the program works. The documentation is very helpful if programmers are unfamiliar with the system and must troubleshoot it during an emergency. So as I mentioned in a previous slide, this has the programming code. So programmers can look at the code to see if there's any errors or bugs occurring. The primary users of this type of documentation naturally are programmers. The elements that this documentation captures include the programming logic, data input and information output, and the program source code. And what you will find in this type of documentation includes flowcharts, source code listings, record layouts, and enterprise relationship diagrams. Now we move on to operator documentation, and this is often referred to as the run manual, and it provides information necessary to execute the program and make it work. The primary users of this documentation are computer operators. The elements that are captured includes the required equipment and supplies, the various execution commands, error messages, verification procedures, what the expected output is, in case there's a problem, what the troubleshooting guidelines are, and protocol for backup and recovery data. And in this type of documentation, we have our narrative descriptions and flow charts. We don't have those ERDs anymore. And lastly, we have user documentation, and this is the documentation that we as accountants are interested in. And this documentation is the content provided to system users to ensure that they are successful at using the system. So this is the instruction guide, the how to do things. In terms of the primary users, we have our end users that are using the system to perform their jobs, as well as auditors who are reviewing the documentation to compare how the system should be used versus how employees are actually using it, to ensure that there are no control issues or there's no risk or fraud or financial statement misstatements. Then we have the elements that are captured in these types of documentation, how to use the system, such as various tutorials, system functionalities and features, tips such as frequently asked questions that must be answered, common errors that might occur in the system and how to troubleshoot and resolve them, instructions for inputting data into the system, instructions to request reports from the system, and procedures to ensure that data is accurate. And the various types of documentations that you will see in the system are narrative descriptions and flowcharts. Based on what we've talked about so far, you should be able to explain why a company must use documentation. You can also should be able to answer the question 2, which is what is the best documentation to use in outlining how to resolve system errors, and why is it better than other types of documentation. Now we are going to look at various documentation techniques. There are many benefits to documenting processes and just having documentation. And these benefits include an efficient transfer of knowledge. So for example, if you are promoting an employee or an employee decides to leave your company, another employee can take the job and it'll be much easier for them to do the job if there is adequate documentation saying what the various procedures and processes involved and the steps how to accomplish things. So for example, if we have an accounts payable clerk that has a process for paying the vendors and making sure that vendor invoices are accurate if they leave, and another clerk comes, they're just able to look at the documentation and know what to input in the system, whose signatures are required, etc. It standardizes processes, especially in large organizations that have multiple employees performing the same role. You can look for process improvements. Once you have a process documented, you have the ability of critically analyzing that process and seeing if there are any bottlenecks, if there's any redundancies, and if there are any ways to make the process better. And it is effective for audit purposes, as I mentioned before, that auditors can look at documentation and compare it to what employees are actually doing. Now let's talk about some documentation techniques. Documentation is used to create, capture, evaluate, and audit processes in our accounting information system. So it is very, very important. And the appropriate type of documentation is contingent on what is being documented and how the documentation will be used. Are you documenting the overall business? Are you documenting processes and systems? Or are you documenting data? These are different things that are frequently documented, and whether or not your documentation fits into these categories will determine the technique that you will be used for your documentation assignment. Let's look at documenting the overall business. Documenting the business involves capturing the people who work there or the states of operations and internal controls. An organizational chart, often referred to as our org chart for short, is a diagram that illustrates the employees in the company and the reporting relationship to another. So this is one way you can document an overall business, is look at the organizational chart. What kind of departments are there? What kind of divisions? Is it a flat organization? Is it more of a hierarchical organization? Sometimes people outside the business, like auditors, need to understand what is happening. They may use checklists or questionnaires to gather information about specific procedures and internal controls. And there's different levels of org charts. I've seen org charts done for an entire company at a more high level, and then each department might be further broken down into a little department org chart. As I mentioned in the previous slide, we might have tall or flat organizational structures, or in other words, vertical or horizontal structures. Here is our example of a vertical structure, or a very hierarchical structure where we have a director, then we have a manager, then we have another manager. So we have a senior manager, a regular manager, and then we have these employees who are analysts. In comparison, this is a more flatter or horizontal organization where we just have a director and everyone reports to the director. So there's no reporting relationships between the senior manager and manager. Everyone reports directly to the director. There are various options of documenting processes and systems. You can either use narrative descriptions, which are just paragraphs describing what happens, or you can use more complex flowcharts. The advantage or benefit of using a narrative, it is much easier to update than a flowchart because you're not adding symbols or deleting symbols. And flowcharts may only be used for critical processes and systems, while less critical items will just have narrative. So a company might use a combination of both. They might say, you know what, these are really important, we want them in a flowchart. These are less important, we'll just put them in a narrative. So it's always basically a cost-benefit analysis, trying to decide what's best for the organization. As I mentioned in the last slide, narratives are just written descriptions of systems and processes as a form of documentation. They describe responsibilities in detail, as well as the processes and controls that are in place. A narrative is often accompanied by a visual depiction, such as a flowchart. So you can have a combination of both. So you can look at a flowchart and then read a narrative to obtain some more detailed, because there's usually more information held within a narrative, but the flowchart provides you with a better visual view of what is occurring. I feel like we've talked about flowcharts for a while, but let's define them. A flowchart depicts the actions or movements of individuals or items in a complex system or process. The type of flowchart used depends on the focus of the end user. So you have document flowcharts, system flowcharts, program flowcharts, and process flowcharts. Let's discuss business process model and notation. Business process model and notation is a documentation method that depicts the steps of a business process from start to finish. Like process flowchart, business process model and notation creates a visual that can be easier to understand than a narrative description. Process flowcharts and BPMNs differ in the shapes and technical layouts they use, but they both serve the same purpose and can be used interchangeably. based on the preferences of the creator or the business stakeholder who will use the visual aid. We always have to document data, so while system flowcharts capture the flow of information through a system, sometimes more technical documentation is needed. In such cases, developers create documentation that captures both the movement of data within a system and how data is stored in its database. How data flows can be captured with a data flow diagram, which is a graphical representation of the flow of data in an information system. The advantages of these data flow diagrams, or DFDs, include they show system functionality and the limits of the system. They document a business process from the perspective of its related data. So you really understand where data is inputs, data outputs, data transfers, data flows, etc. These are usually easier to use than a text description. They offer an easy to understand system diagram for users to comprehend the data flow. They can help new employees to understand the system and how it works. And they allow auditors to familiarize themselves with the systems that they're auditing. Then we have our entity relationship diagrams, or ERDs, which are graphical representations of all the tables and their relationships in a database. We've touched upon this in Chapter 6 when we discussed databases and how they all fit together with primary keys and foreign keys. And ERDs are just a graphical representation of all the tables and the various connections to them. There are 3 types of entity relationship diagrams, and we can use this nice table that compares their complexity and their use. The simplest model is our conceptual ERD, and it is used by business and users and database designers to capture business needs and to understand the general plan for the database. Next, we have our logical ERD, which is more detailed than our conceptual ERD, and this is used by database designers to refine the business needs of the database and begin modeling data at a more technical level. Lastly, we have our physical ERDs, which are most complex, and they're created by database designers and used by database administrators and developers, along with a database schema to build access to the database. And then let's also compare these ERDs in terms of the requirements. With a conceptual ERD, you're looking at table names and lines connecting the related tables together. With logical ERDs, you'll have table names, lines connecting the tables together, and list of fields that are included in each table. So in your midterm exam, you had various fields provided and you had to kind of put those fields and assign them to a table. This would be depicted in a logical ERD. And then with a physical ERD, you not only have table names and lists of fields in this table, but also the different data types. Is it alpha? Is it numerical? Is it a combination of both? Restrictions to be programmed into the database, and technical details about how each table is connected to one another. Here's a fun little question you can ask yourself if you have time. An organizational chart is a diagram used to illustrate employees within an organization and the reporting relationship between these employees and groups of employees. The main types of organizational structures are tall versus flat. So we have our vertical versus horizontal, and these have many advantages and disadvantages. If you were creating a new startup company to build small workbenches for a local hardware store, which organizational structure would you likely use in the beginning and why? Once an organizational chart is chosen, do you think it can be changed? What are the possible outcomes of changing an organizational structure? Are there any risks that you can think of? Now let's look at how a flow chart illustrates a system or business process. Here is a very simple flow chart. So one thing you will notice, you always start with a circle and write down what is occurring. And then you end with a circle to show that the process has ended. So here we have a customer who orders a chicken biscuit. The server asks them whether or not they want a coffee. This is kind of a decision point, and with a decision point you will have a yes path or a no path, a true path or a false path. So in this case, if they want a coffee, then they order the coffee as well, and then the order is finished and then put it into the system, and the customer receives what they asked for. If they don't want a coffee, then the order's just finished and they get their chicken biscuit. So you will see there's various symbols in the chart, and we are going to learn those and we are going to use them in the next few classes. So as we saw in the last slide, a flowchart consists of various shapes, each with its own meaning. The type of flowchart determines which types of shapes are going to be used. As I mentioned when we reviewed that flowchart, you always have a circle that is the start or an end of a process, and this terminator shape marks the start of end or processes. It can be filled with either the word start and end or a description of the beginning of the process. So what occurs at the beginning of the process? The flowcharts in this chapter you start, but you will encounter process flowcharts in other chapters with more specific beginning terminators, such as decision to extend an offer to a candidate or year-end reporting begins. Please note that every flowchart must start and end with a terminator. So if you are doing a flowchart on the exam, make sure you have a start and an end because these are easy marks. Next, we have this rectangle shape, also called the process shape, and this represents an event or stop within the flow. A flowchart could be as detailed as having a process shape for every step of baking cookies, such as add 1 egg followed by stir ingredients together, or a journal such as bake cookies. The level of detail really depends on the organization, who the end user of the flowchart is going to be, and what their information needs are. Note, a process shape always has a single line entering it and can have multiple lines exiting it. This is because flowcharts can split into two paths if a process event results in two subsequent events, such as sending an email to two different departments. You have to connect your flowchart, and you do this with an arrow known as a flow line. And the flow line connects shapes together. Each shape in the flowchart must have at least one incoming flow line and one outgoing flow line. Unless it is a terminator, then you don't have an outgoing flow line. The arrow of the line points to the direction of the flowchart flow. And please note that flowcharts cannot have arrows on both sides, so you can't have things coming in and coming out of a process. Then we have a decision point or a diamond, and this shape represents a yes or no or a true or false question that must be answered for the process to continue on the correct flow line. When the flowchart reaches a decision, it splits into two branches, one for the yes and one for the no. For example, if a customer orders a cookie, there is a decision to whether the order is placed in store or an app. You'll see a decision for purchase in store. In the process flowchart example that follows, note that a decision shape must have a single flow line entering it and two flow lines exiting it, because there's that true, false, yes, no decision occurring. We also have this downward pointing triangle or a merge shape that connects two or more paths of a flowchart into a single flow line. There is no limit on the number of paths that can merge through this shape, but please note that a merge should always have multiple flow lines entering it and a single line exiting it. You will see examples of flowcharts complex enough to require merges in our business process chapters that we are going to do in the coming weeks. Some flowcharts can be very, very big and they may not fit on one page. So when you have multiple pages, you use a connectors, and the connectors are always filled with a letter. You'll start with letter A, and the connector on the first page appears at the end of the flowchart on that page, and then it appears at the beginning of the next page. And the letter inside of the two related connectors have to be the same, so you know where the flowchart ends on one page and begins on the next page. Essentially, you end at A on page 1 and begin with A on page 2 or the next page. And we will see examples of flowcharts using connectors in our future chapters, so we are going to be doing that. Here are some additional shapes. For our purposes, we will not be using them in an exam setting, but they're good to know as a reference. We have a document, which is basically a rectangle with this wavy bottom, and it represents that a physical or digital document such as an email, report, purchase order, or invoice is being generated. Then we have a parallelogram, which signifies input or output. And this shape represents data or information coming into the process or leaving the process, such an order coming into a bakery. Then we have this lovely cylinder shape, which denotes a database. And this represents data storage. And that data is inputted into the database and information can be retrieved later on. Then our trapezoid, the various types of trapezoids denote either a manual input or a manual operation. You will not need to know these for our exam, but they're good to know in case you are working and looking at flowcharts. So the manual input shapes depicts data that is manually inputted into the system, such as a user typing in their username and password to access the system. And our manual operation shape is used if the user physically takes an action, such as taking a print out of a report and placing it on someone's desk, or physically placing freshly baked cookies on a cooling rack if we are documenting a baking process. And please note that manual operation is different from manual input, as no new data is being inputted into this system during a manual operation. So you're not inputting data, you're just doing something that requires a human to perform the task. It's not an automated task. Here we have an example of a high-level sales process. Please notice we have our start and our end, and we have multiple ends because we have this decision point and the processes never merge together with our little triangle. So here we have Julia Cookies orders and receives fresh local ingredients. The factory mixes and freezes cookie dough. The dough is put on a truck that delivers it to a store. And now we have a customer purchasing an order. And this is our decision point where we ask the question, is the order placed in store or is it placed online? If the customer places the order in store, they pay for their cookie at the register. The store bakes that cookie and the customer receives the cookie. Alternatively, if they order it outside of the store, let's say on an app, then the customer will pay through the mobile application. The store will still bake the cookie, but now we have a delivery driver that needs to drive to the customer to provide them with the cookie. The customer receives the cookie and the process ends. If a process is very complicated and involves multiple departments, you can use something called swim lanes, which are areas within a flowchart that delineate the responsibilities for all activities involved in the business process. Swim lanes provide clarity and accountability by placing activities within the swim lanes of particular individuals, groups, or departments. They show the handoff points between the different contributors, and they help identify inefficiencies, redundancies, or waste in the process. Here we see an example of swim lanes. So we have our different departments. There's the purchasing department and what they do, our receiving department, our factory bakers, our shipping department, the regional store, and what occurs with the customer. So as you can see, this is more organized so you know who's accountable for what. So swim lanes provide readers of flowcharts with more information. If you have time, you can try to answer this question. During a training session for process management employees, you are asked to demonstrate your familiarity with flowchart symbols. For each of the following shapes, describe what the symbol represents and give at least 2 examples of how the shape can be used within a flowchart. So the database symbol, the decision symbol, the document symbol, and the manual operation. Remember, for your exam, you'll just need to know the decision symbol. Now let's look at data flow diagrams and discuss how they depict the flow of information in a system. In comparison to our flowcharts, our data flow diagrams are created using only 4 shapes. It's very important for you to remember that data flow diagrams also use rectangles, but although they look the same, they symbolize something very different than what they symbolize in a flowchart. So please try not to get confused. So here is that rectangle we talked about, and in data flow diagrams, it represents an external entity. So what an external entity is an input or output of this data flow diagram. These entities are called external because they are either entering the system from an external place or are exported out of the system to an external place. So for example, if we are inputting information into a system, this information would be coming from an external entity. For example, if I'm back to that accounts payable clerk and I received a vendor invoice, I would be inputting it into our system, and that invoice in that case is the external entity. External entity shapes are often the beginning and ending shapes of our data flow diagrams and can be called terminators. In contrast to our flowchart terminator, an external entity cannot just state start or end. it must name a real entity that is providing or receiving the data, and our external entities only provide or receive data. They do not process the data. This is our process shape, and it has a line on top, and it represents an activity that transforms or changes the data. A decimal number such as 1.0 label identifies the process for a quick reference. Processes are always expressed as a singular verb or a singular noun, such as verify order or apply payment. And a process shape must be connected to at least one external entity. So we have that vendor invoice that now is entered into the system by verifying the order. Our next shape that we will discuss is the data store shape, and this represents a data repository such as a database or a data warehouse. Our data store retains data for later use. A data store can also be the beginning or ending of our data flow diagram, and the D and numeric such as the D1 label identifies the data store for a quick reference. So here is our label so you know which data store it refers to. The name of a data store describes what the data store is holding, such as inventory or orders as an example. Now we have our data flow arrow, and this illustrates the movement of data between external entities, processes, and data stores. The data flow line is labeled with the type of data being transmitted, such as our purchase order or order data. And data flow lines can have arrows at both ends to depict a two-way flow of information. And unlike our flow lines in a flow chart, which must always move in one direction. So here you can have your lines moving in multiple directions. Here's an example of a simple data flow diagram. We have a customer who is placing an order. So here we see the word order, so we know what they're doing. The order is entered into the system, and this is the order data that is stored in our orders database. There are different levels in a data flow diagram, and there's usually 3 of these levels. Each new layer adds details and complexities of the data flow. To find the inefficiencies in the data flow, an IT professor might depend on the greatest level of detail that is offered in a diagram, while business end users may prefer a high-level overview of the data flow diagram to understand the big picture of how the data flows in and out of the system. So the first level is level 0, and these are also referred to as context diagrams, and they're just a summary that gives a high-level overview of the data flows. Here we have an example of a level 0 data flow. We have customers, suppliers, Julia's Cookies Bakery, and Julia's store manager. And we have the cookie ordering system and how all these stakeholders are impacted by it. The next level of DFDs are the level 1 diagrams, and these highlight the main functions carried out by the system, and they drill down further into the DFD processes by decomposing the system, and this breaks down each process into further sub-processes. Here is an example of level 1 DFD. As you can see, there's much more details. We see what is happening with each data flow arrow. Customers place orders. Orders are stored in inventory, and you can generate various inventory reports. And you have a different orders database that also is used for reporting. Julia Cookies Bakery needs the orders being transmitted to them. You have a store manager reviewing the reports and, if necessary, ordering more inventory from the supplier. So as you can see, this DFD is much more complex and offers us much more information. And then lastly, we have level 2 diagrams, which are the most detailed. We have process numbers including decimal points to indicate sub-processes of the level 1 process. A level 2 diagram allows the end user to understand the system and process in detail and depth. And this type of diagram assists in identifying control weaknesses or any process inefficiencies. So here we have our little sub-process. We have our customer ordering. We have bill preparation, which we didn't discuss in the other diagrams. And we have the store manager then handling the bills. And then we still have the bakery receiving the orders. And here we have the order information being recorded in inventory, because you have less inventory if there's an order, and then you also have your orders table. If you have time, you can attempt to answer this question. You are a senior internal auditor who works at Beeman Sports, a local sporting goods store. You have been assigned to mentor Kelly, who is a first-year associate on your team. During your monthly peer meeting with Kelly, she mentioned she was recently asked to create a flowchart of a business process for an audit engagement, but the audit manager sent back review notes on her diagram, mentioning that it's more of a data flow diagram than a flowchart. Kelly is confused about the differences between those two documentation methods. Could you explain to Kelly the difference, how they're used, and what are their purposes? So I think I went ahead and I said this information in the last slide, so my apologies. Thank you so much. I hope that you found this lecture helpful, and as I mentioned, we will be looking at process diagrams and diagramming various process flows for the next 3 weeks. So looking forward to that with you. Take care. Bye.